Question number 14, we need to simplify the expression sine square t plus cosine square t divided by sine square t. Immediately we notice that the numerator, sine square t plus cosine square t, is basically equal to 1 from the Pythagorean identities divided by sine square t. We can rewrite this expression as 1 over sine t all squared. We know that the reciprocal of sine is cosecant t all squared, which can be written as cosecant squared t. So this expression reduces to cosecant squared t. Question number 15. We know that cotangent is an odd function, so the negative is going to come out. And we know that cosine is even, so the negative is going to cancel. Sine is odd, so the negative is going to come out. Now, this is going to become cotangent, negative cotangent x times cosine x minus sine x. Cotangent is equal to cosine over sine, cosine x over sine x times cosine x minus sine x. We need to have the same denominator so we can combine, which means I'm going to multiply this term by cosine sine x over sine x. So we will have negative cosine times cosine is cosine square x minus sine times sine is sine square x. Everything is divided by sine x, the common denominator. I can pull negative out as a common factor, or negative 1 out as a common factor. I will have cosine square x plus sine square x divided by sine x. The numerator, this expression, is equal to 1. So 1 times negative 1 is negative 1 over sine x, which is equal to negative, the reciprocal of sine is cosecant x. So it's negative cosecant x, so this expression reduces to negative cosecant x. Question number 16. We need to simplify the expression tangent square minus secant square is equal to something that we need to simplify. We know that tangent square x is equal. I'm going to replace tangent in this expression with its equivalent, so I can write it as secant square x minus 1 minus secant square x. I notice immediately that secant is going to cancel with secant. Secant squared minus secant squared is 0, and I will end up with negative 1. So the final answer for this expression is equal to negative 1. Number 17. For question number 17, we need to solve inverse sine of pi over 6. The first thing you should notice is the range for cosine. The range for inverse sine is either in the first quadrant or second quadrant, and it is between negative pi over 2 and pi over 2, meaning the angles in the fourth quadrant have to be measured in negative. They have to be the negative angles, not the positive angles. So sine pi over 6, pi over 6 is right here, sine pi over 6 is equal to 1/2. So this becomes inverse sine of 1/2. The angle that gives a sine of 1/2 is pi over 6. And that is the answer. That is the final answer. The angle theta that gives you a sine that is equivalent to 1/2. So theta or x or whatever is equal to pi over 6. And we're going to stop because pi over 6 happens to be in the first quadrant, so we're good. Question number 8, similar to the previous question, but a little bit different. Again, remember that the range for sine, inverse sine, is between negative pi over 2 and pi over 2. So we need to find inverse sine of 7 pi over 2. 7 pi over 2 is basically, here is 2 pi over 2, and then here is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So this is 7 pi over 2 right here. The sine 7 pi over 2 is negative 1. So inverse sine of negative 1. We're looking for theta such that sine theta is equal to negative 1. That angle is going to be 2 pi over negative, sorry, it's going to be 3 pi over 2, but we're working in this range, so it's going to be negative pi over 2. So that is the answer for this question. Question number 19. We need to evaluate the expression sine squared plus cosine squared when x is equal to 30. This is the Pythagorean identity, and it's always equal to 1, no matter what x is equal to. So this expression is equal to 1. The answer is 1 here. Number 20. Find the exact answer for sine 285. Sine 285. We don't have the 285 from the unit circle, but if we use two angles from the unit circle and add them up, we're going to end up with 285. I see 5 here, so immediately I'm thinking about 45 as one of the potential angles. And then the other angle is going to be 240. We need to find sine 45 plus 240 or 240 plus 45. I'm going to use the sum formula for sine. To remind you, the sum formula for sine says sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So this is equal to sine 45 cosine 240 plus cosine 45 sine 240 degrees. Now, using the unit circle, I know that sine 45 is square root of 2 over 2. Cosine 240 is negative 1/2. Plus cosine 45 is square root of 2 over 2 times sine 240 is negative square root of 3 over 2. This is going to become negative square root of 2 over 4 minus negative times positive is minus square root of 6 over 4, which can be written as square root of 2 negative square root of 2 minus square root of 6 divided by 4. And that is the exact answer. You can just leave it like that. Question number 21. I need to rewrite the expression cosine x plus 5 pi over 4 in terms of sine and cosine. So in this case, we're going to use the sum formula for cosine. The sum formula for cosine says cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. So applying this here, this will be equal to cosine x cosine 5 pi over 4 minus sine x sine 5 pi over 4. Now, looking at the unit circle, I know that sine and cosine pi over 4 is both negative square root of 2 over 2. So this becomes cosine x times negative square root of 2 over 2 minus sine x times negative square root of 2 over 2. If I wanted to simplify this a little bit, I'm going to bring the number in front of cosine and in front of sine. So this is going to become negative square root of 2 over 2 cosine x, or I can just pull it as a common factor, minus sine x. So what I did here, I pulled negative square root of 2 over 2 out as a common factor, and then you're going to end up with this expression. Number 22, we know that cotangent is equal to cosine over sine. So this is equivalent. So cotangent pi over 2 minus x is equivalent to cosine pi over 2 minus x divided by sine pi over 2 minus x. I know the numerator is going to be cosine pi over 2 cosine x plus sine pi over 2 sine x divided by, the denominator is sine pi over 2 cosine x minus cosine pi over 2 sine x. I'm using the difference formula for sine and cosine in this case. Cosine pi over 2 is equal to 0. So this is going to become 0 times cosine x plus sine pi over 2 is 1 times sine x divided by sine pi over 2 is 1 times cosine x minus cosine pi over 2 is 0, 0 times sine x. So this expression is gone. This is 0. And this expression is 0. So this expression is 0. I have on the numerator sine x, and in the denominator I have cosine x. So this is going to reduce to tangent x. And I kind of knew that from the beginning because I know that the co-functions are equal if their angles are complement of one another. And I know that pi over 2 minus x is a complement if a complement of x, because pi over 2 minus x plus x equals pi over 2, and that proves they are complements, which means cotangent of pi over 2 minus x is equivalent to tangent the complement of pi over 2 minus x, which is x in this case. So I could have reached the same conclusion just by thinking about complement angles and cofunctions.